Hi everyone. Note 6.8 are on mixed trig problems. The trig isn't so bad when you are learning it individually, but once it's all mixed together, it's a little bit harder. So we need to figure out ways to identify what kind of trig questions we have going on here. So here's a little chart to help you understand what to do. This side of the chart tells me what I know. So I'm going to take a look at my picture. I'm going to see what I know. This side tells me what I want to find out, and then this side will tell me what I should use. Okay? So if I'm given two angles of a triangle, so for example, if I know in my triangle that this angle right here is 40 degrees, this angle right here is 80 degrees, and then here it tells me that I want to figure out the third angle of a triangle. What should I use? I should use the fact that the sum of angles in a triangle is 180 degrees. So I would just add the 40 and the 80 together. I would get 120, subtract 120 from 180, and I would know that the missing angle is 60 degrees. Okay? What if I'm given a right triangle? And by the way, this is any triangle for this one right up here. What if I'm given a right triangle and I'm given two side lengths? So let's say, for example, I know this is 5 and this is 13. And then the thing that I want to find out is the third side of a right triangle. So I want to know this side right here. There's no angles at all, so I actually wouldn't be using trigonometry at all here. And in fact, I would actually be using Pythagorean Theorem, which is a squared plus b squared equals c squared. All right, if I am given a right triangle, and then again, two side lengths, but this time what I want to find out is an angle in the triangle. So let's say I want to find out this angle right here. I would not be able to use Pythagorean theorem because I don't know. I'm not trying to find a missing side. I'm trying to find a missing angle. And just a reminder that trig connects angles to sides. So right here, an angle in the triangle, if I want to find that, then what I would use for this are my trig ratios. And just a reminder that my trig ratios are SOHCAHTOA. But because I want to find an angle, that means that I'm going to use an inverse ratio. So I'm either going to use inverse sine, inverse cosine, or inverse tangent, depending on the sides that I know. Okay? What if I'm given a right triangle again, but this time I'm given a side length and I'm given an angle? I want to find another side length. So like, let's say, for example, I want to find this side length right here. It doesn't necessarily have to be the hypotenuse. I'm just giving you an example. Still, I would use my trig ratios. So I would still use SOHCAHTOA. But because I know an angle, I don't need to do inverse. I would just use the regular ratio. Okay? So what happens now if I have an oblique triangle? So just a reminder, an oblique triangle means that it is not right. And if I'm given an angle, I'll draw it over here because I have more space here, and its opposite side. So let's say this is 35 degrees, and I'm given that this is 7 right here, and I'm given any other measurement at all. I just have a matching pair pretty much. And I want to find another angle or another side length, then I would use sine law. If I'm given an oblique triangle and I'm given three sides, so let's say this is like 7, 8, and 9, and I'm trying to find an angle. So this time what I'm trying to find is this angle right here, for example. This is where I would use the cosine law. But again, because I am trying to find an angle, I'm eventually going to have to do inverse cosine of some number to solve for the angle. Okay, and then lastly, if I'm given an oblique triangle, so again, not a right triangle, and if I'm given two sides and a contained angle, so let's say this right here was 41 degrees, and I'm trying to find a side length, which is the only side length that's left over, so it's always the one across from it, the opposite side to the angle that's given, then I would be using the cosine law. But because I know an angle, I don't have to do inverse cosine. Okay, so let's put this to practice. So for these questions, I'm not going to actually solve them. I'm just going to determine what method I need to use to solve for x. So in this first question right here, the information that's given to me is, I'm told, 3 side lengths. And what I want to find out is the missing angle. So I'm going to take a look at what we have here. I'm not told 2 angles of any triangle. I am not told that I have a right triangle, so it's none of these. I am told I have an oblique triangle, but I don't have an angle on its opposite side. I don't even have an angle at all, so that's not going to work. I'm told I have an oblique triangle and I have 3 sides, so that means that I'm going to have to use cosine law. But because I am told to figure out an angle, I'm going to have to do inverse cosine. All right, let's take a look at our next one. In our next one, I'm given an angle and its opposite side. I'm also given another side. So here I have a matching pair. I'm also given another side, and the angle that's across from it is what I want to find. So let's talk about this again for a second right here. So here I don't have 2 angles where I'm trying to figure out the third one. It's not a right triangle, so I'm going to go back to oblique triangles. I do have an angle and its opposite side, and I have one other measurement. So I actually can use sine law for this. But just a reminder, we're going to have to do inverse sine because we're trying to find an angle. However, if you notice, we actually have 3 different sides. So this could actually be just like this question right here, and we could use cosine law. So at that point in time, it just comes down to your personal preference. So I want you to write yourselves a note that we can also use cosine law for this one. Okay? In number 3, I am given 2 angles right here, and I'm also given 1 side length. However, I need to do an intermediate step to find the third angle in a triangle. So I can actually find the third angle in this triangle first. So it would be 180 minus 37 plus 45. So that would be 180 minus 82, so I would get 98 degrees. So I know that this right here is 98 degrees. Now I have an angle, and because I have an angle and its opposite side right here, and it's an oblique triangle, and then I have another angle that I can use to help me find its opposite side right here, I can use sine law for this as well, okay? All right, in our next one, we are given that we have a right triangle right here. So the fact that this is a right triangle is going to help us. And we're also given 2 side lengths, and we're trying to find a missing angle. So let's go to our list right here. We're not asked to find a third angle of a triangle. We do have a right triangle, and we are given 2 side lengths, but we're not trying to find the third side of the triangle. We have a right triangle and we're given 2 side lengths, and we're trying to find an angle in the triangle. So this is the one we're going to use. So we're going to use our trig ratios. But because we're trying to find an angle, we are going to do inverse trig ratios. So here I'm just going to write down SOHCAHTOA, but we're going to do an inverse one. Okay? All right, in our next one right here, we have an oblique triangle. And we know 2 sides and the angle that's included between them, okay, the contained angle, and we're trying to find the side that's across from it. So let's go through our list. We're not trying to find 2 angles. We're not trying to find the missing angle of a triangle given 2 angles. It's not a right triangle. We have an oblique triangle, but we don't have an angle in its opposite side. So we're not going to do that. It is an oblique triangle, but we don't have 3 sides. It is an oblique triangle, and we have 2 sides and a contained angle. We're trying to find a side length, so we are going to be using cosine law. What I would like you to do, please, is try questions 6, 7, and 8. Pause, come back to see how you did. I'll give you the answers. And if you did not get the right answer, please ask me next time you see me in class so I can help you figure out what went wrong. Okay? So for this next one right here, we are given a right triangle. Okay, we are given an angle and a side. So that means that we are going to use trig ratios or SOHCAHTOA. And I forgot to say that we're trying to find opposite side. In our next one, we are given that we have a right triangle and we have two sides, and the third thing that we want to, and the thing that we want to find out is a missing side. So for this, we're going to use Pythagorean Theorem, which is a squared plus b squared equals c squared. If you wrote down Pythagorean Theorem, that's totally fine as well. Okay, and in our last example that we have here, this one was a tricky one because we are given two angles. We need to find our third angle right here, which we can actually find using the sum of the angles in a triangle. But that's not all we're going to do. So once we find out what that angle measurement is, which is 71 degrees, we now have an angle and its opposite side. We also have other angles and we're trying to find another side. So here we are going to be using sine law after we find the missing angle. If you wrote down sine law and that's it, that's totally fine because we didn't write down right here that we would be using the sum of the angles in a triangle. Okay? All right, and that's it for this video. Let me know if you have any questions. Otherwise, I will see you in class. Bye.